We are going to look at Lab 13 now. Lab 13 has several parts. In the first part of this lab, you will learn how to identify expansion cards, both by the kind of slot that they will insert into on a motherboard and what kind of purpose they serve or what kinds of devices we connect to them. We'll start by looking at the photos here in this document for Lab 13. You'll want to have your Lab 13 sheet ready, and you'll be filling in the first part of this first page for this lab. Here for card 1, we have an expansion card, and the first thing we want to do is figure out what kind of slot this would go into on a motherboard. To determine this, we look at a couple of different things. We look at the offset, which is the distance from the back of the card to the beginning of the pins on the card. All right. Now you'll notice that in this picture, this offset is fairly small. It's probably about an inch in real life. All right. The other thing that you'll notice is that we have pins along the bottom of the card, and they are divided into two main groups, signified here by the separation between the material that the card is made of. So here's a short section and here's a longer section. So we have pins in two groupings. Another thing that we'll notice is that these pins are pretty distinct. We can easily see them. They're kind of widely spaced, and there are gaps in the material of the pins. All right, all of these help us determine what kind of slot this particular card goes into. Now, if you look at the reference document for this lab, you'll see different expansion slots in that document. And if you look at the first two slots on that page, you'll see that they both have a short offset, the distance from the edge of the motherboard to the beginning of the slot, which is roughly the same size as this offset, from the back of the card to the beginning of the pins. Next, you want to look for the slot that has two distinct groupings. In other words, in that slot, you will find what I like to call the little humpy place that the card goes over to line up properly with the slot. Technically, that's called a key, but I think a little humpy place is pretty distinctive and descriptive. So we can see that by matching the offset and the pin groupings, that card 1 would go into the slot labeled 16-bit ISA. All right, so that's what you put for the bus, 16-bit ISA. The distinguishing characteristics would be the small offset, about an inch, two groupings of pins with widely spaced wide pins. Okay, now as for the purpose of the card, we're going to come down here and look at the ports on the back of the card. Notice that there's very little on the card itself in the top image that indicates what that card is or does. Sometimes you will find a clue, sometimes you won't. So it's best to look at the ports on the back of the card. Here we have 4 small round ports and a DB15 pin port with the pins in 2 rows. All right, that port is the old MIDI port or game port, which was found on early generation computers. These 4 little round ports are audio ports. And if we could see the printing on the back of the card more clearly, it would say something like line in, mic, headphone, speaker, or something similar. So this particular card is a sound card. All right. Let's take a look at another one and see what we can figure out. This is card number 2. Okay, right away we can see that it looks a little familiar in terms of the pin and offset configuration. Here the offset from the back of the card to the beginning of the pins is fairly small. It looks a little bigger in this picture because of the resolution that the picture was taken at, but it is actually the same size as the offset in photo 1. Also notice that there's one main grouping of pins. There's no little cutout here to go over a little humpy place in an expansion slot. Also, these pins are wide and fairly widely spaced, and there appear to be some pins missing. So if we go back to the reference document and look at the expansion slots, this looks a lot like it would go into the 8-bit ISA slot on a motherboard, and that is correct. Now, you could also put this card into a 16-bit ISA slot with no problem. It just simply wouldn't fill the second half of that slot. Functionality would not be affected. Now, as far as what this does, we look at the ports on the back here, and the labels on these 2 RJ ports pretty much give away what this card is. One of these ports says line in. The other one says to phone. All right, this is made by US Robotics, and if you guessed that this is an internal modem for dial-up access, you would be correct. This is a dial-up modem. And this card is old enough, being an 8-bit ISA, that it did not connect at a very high speed. So we should all be thankful that we no longer have to use dial-up modems and have slow internet connection speeds through them. Oops, let's go back up here to card number 3. We got a little excited there. All right, this card looks a little different. If you look at the offset, again, it's fairly small. It seems to match the offset of the 8 and the 16-bit ISA cards. We have one grouping of pins, a second grouping where there actually are no pins, and then a third and a fourth grouping where the pins look different. Now this is kind of a hybrid card. This was around for actually a fairly long time, but was found only on one particular generation of motherboards. If you look on your reference document, you will see that there is a very long slot which could accommodate connectors in this arrangement. A large group here toward the outside end, a smaller group, then a different size larger group, and a very small group at the end. if you deduce that this card is a Visa card, you would be correct. All right, now the thing about the Visa card, a particularly distinguishing characteristics is that the pins are different on both ends of the card. Toward the back side or outside of the card, they look like they did on the 8 and 16-bit ISA cards. But on the inside end, they're thinner, they're closer together, and they just generally appear to be smaller. And that would be so that they would fit into that different colored end on the Visa expansion card. As far as what this card was used for, originally Visa cards were brought out for one particular function. And if we look at the expansion port on the back of the card, you'll see that there are 15 holes in it, and they are arranged in 3 rows of 5. And this is, of course, a VGA port or video port. So this is a video card for attaching a monitor. All right, let's go on and look at card number 4. A moment here. Aha! Something is looking a little different. When we look at card 4, right away we can see that the offset is larger. This is at least 1.5 inches, maybe even close to 2 inches. And we have pins that are skinnier and more closely packed together. And we have 2 groupings, a large grouping and then a very small grouping. Okay, so if we look at the expansion slots, we see that the 8 and the 16-bit ISAs and the Visa slot are no longer in the running because their offsets are too short. We need a slot that has a bigger offset or a larger distance from the edge of the card, from the edge of the motherboard rather, to the start of the slot for the pins. This slot for this card is going to be the PCI slot. All right, and those distinguishing characteristics again, larger offset, 1.5 to 2 inches in fact, thin, closely spaced pins with a large group and then a small group. Those would be the characteristics. Look at the connections on the back of the card. In fact, there is only one port. It says data on one side. It says what looks like TX and then 100. And if we could count the little connectors inside of this port, we would see that there are in fact 8 of them. This happens to be an RJ45 port. So this would be a network card for typically Ethernet cable. All right. Let's go on to the next card. Aha, card number 5. Here we have some new distinguishing characteristics. A very large offset. This has got to be at least 2 inches. All right. We have 3 distinct groupings of pins, and interestingly enough, it looks like there is a double row of pins. Right here on the bottom of the pin place are some small pins, and then above appears to be a second row of pins. All right, so we've got 2 rows of pins, a very large offset. Looking at the reference document with the expansion slots, we can see that there is only one expansion slot that has an offset that large. And that would be the expansion slot for the AGP types of expansion cards. Now, AGP stands for Accelerated Graphics Port, and that gives you an indication of exactly what this card is for. When we look at the ports on the back of the card, we can see that we have two VGA ports, meaning this is a video card for dual monitors. All right, AGP was always for video. It wasn't used for anything else. Let's go on to card number 6. Well, this is interesting. We're back to a single row of pins, very closely spaced together. And look, the offset is not as big as it was with AGP. In fact, it looks closer to the size of the offset for a PCI slot. But there's a difference. Instead of a large group of pins and then a small group of pins, this card has them reversed. The small group of pins first and then a larger group of pins. There's also a little hook here on the end that helps keep the card firmly inserted all the way into the slot. Previous expansion cards up until the AGP cards didn't have this, and in fact didn't need this. But this is a card we really want to remain seated in the slot, and this hook helps to do that. Looking at the reference document, we can see that underneath the AGP slot, we have a PCI Express by 16 slot. And that would hold this particular configuration of pins and offset very nicely. So this is an AGP, excuse me, not an AGP, this is a PCI Express by 16 card. And looking down here at the ports on the back, not the easiest to see, but here we have an S-Video port, here we have DVI, and here we have VGA. So this is going to be a video card. PCI Express by 16 is almost exclusively used for video cards at the present time. All right, so those are the functions of the first 6 cards on the first page. If you turn the page over and look at the second, you'll see that there's room for a couple of bonus cards. Now, the reason that I included these is even though we don't use these technologies anymore and they're obsolete, they were around for a short period of time, and they did provide some technology that we wound up reusing again later on. So if you look at bonus card 1, it looks a little familiar in terms of the offset. It's about 1 inch. And if you look at the major groupings of pins, you can see that there are 2 major groupings. Even though there are intermediate smaller groupings, and there appear to be 2 rows of pins again, just like we saw in AGP. This happens to be an EISA card, E-I-S-A. And this technology came after 16-bit EISA, and by putting 2 rows of pins on the card, they made this a 32-bit transfer bus. All right, so this was an EISA card. We look at the port on the back. We can see that this appears to be for video. or VGA. All right, so in fact, this was a VGA ESA expansion card. Now, at the same time as ESA was being used, there was another technology being used by IBM PCs, and that used this type of expansion card. We have an offset that looks a little bigger, sort of like PCI or AGP, but the pin configurations are wrong. There are too many pins to fit in either one of those slots. All right, this was the expansion bus called MCA, Microchannel Architecture. This was proprietary to IBM, and if other manufacturers wanted to use this type of expansion card and slot in their PCs, they had to pay royalty or license fees to do so. And they didn't want to do so, which is why they developed the ESA standard. Now, the purpose of this card, if you look on the back at the ports, you can see we have an RJ45 port here, and we also have a different type of port that looks a little bit like a MIDI port, but was in fact used for a connector at the end of a network cable. So this is a network card or a network adapter. You can see on the label of the card itself, it says Etherlink 3 MCA, made by 3Com. So it is in fact a network card. We sometimes refer to these cards as combo NICs, combination network cards, because of the different types of ports that they contained for different types of cabling. All right, so that's a look at the expansion cards for Lab 13. Hopefully you have that first portion of the lab now filled in. You can go on to part 2 of this lab, where you will be looking at Device Manager on your computer. You will be looking at different components and finding the resources that they use and whether or not these components are conflicting with any other devices in your computer. If you have any questions while you're doing this part of the lab, please don't hesitate to get in touch with me. Send me an email and we can kind of walk through it. One thing that the lab does ask is what are the lowest and highest number for the resources that are being used. You do not have to count negative numbers. We are looking for whole numbers from 0 and on up. Part 3 of this lab has you removing an expansion card if the lab PC you're working on has one. If it does not, just ignore that part of the lab and go on to answer the questions on the back of the lab sheet. I will record another audio for those questions. As always, if you have any problems with the lab, get in touch with me as soon as possible. I'm more than happy to help work through any issues that you might have.